So this one I'm going to kind of write it out exactly the way I would suggest to write it out on an AP test in terms of scoring and stuff like that. I'm doing it what I consider to be the most efficient way, but if you have trouble keeping track of when I'm talking about Y1, Y2, stuff like that, you might have to do it a little bit differently. But I just want you to see this way because I think it's super efficient and it's very error-free if you are precise about what you're typing in your calculator. So I've got this equation and this equation. They're both graphed here. I built this graph. I started with a zoom 6 and then kind of adjusted it a little bit until I got to a window that I liked. The key here is that we want to do the integral of the difference of these two functions, but there's two different. Maybe I'll label. So I got green intersection, I got red intersection, and then I got blue intersection, right? So my green intersection to my red, that first region, y2 is on top. So I need to do y2 minus y1. And then they flip-flop here, so I need to do y1 minus y2. So I need to do some extra work to make sure that I include the area in the correct way. So the first thing I'm going to do on my paper is write y1 equals 2x plus 2 and y2 equals x cubed minus 6x plus 8. So next thing I'm going to do is I am going to calculate some intersections on my calculator on that graph. So I'm going to get that red, that blue, the green, red, and the blue intersections. So I do second calc and calculate those intersections. So I want to talk about that new picture that just showed up because that's really important for accuracy. When you calculate this intersection, you get that this is your x value. The y value doesn't matter for us because we're going integrals over dx. You could write this whole thing down and then go back to your main screen and type the whole stupid thing in and then store it as a button, as an A, or even just use that whole written out thing when you're doing an integral, because we cannot round to the end. If we round early, then our answers will get off and we're not going to have the right answer at the end and you'll lose credit. So this keystroke right here that you see in front of you, you can do very easily. You go and you calculate the intersect. It'll tell you that thing. It'll give you the x coordinate, the y coordinate. Then what you're going to do is go back into your main screen. So this is the main screen. And I just hit the X button and it pulls up the x coordinate from that intersection, which is really cool because that saves me a lot of time. I don't have to write it out and then retype it. And then what I'm going to do is store that as A. I'm going to go through and do that with each of these. The red one, I'm going to do the red one and store it as B, and I get B. Actually, I should probably use the approximate sign here, and I should have for that green one, but I'm not going to rewrite it. But B is approximately 0.819, and then my blue intersection, the x value, C, is approximately 2.553. So from here, I would have done this process with each of these. So now I've got these stored in my calculator. This 100% has to be written down on our paper. If you don't write that down, you'll lose credit. You have to write that down. So far, I've written y1 equals this, y2 equals this. You might want to sketch the graph and then write what A, B, and C are. Now that I've written what they are, I can then go, and it might make sense for me to honestly have put this up here, but whatever. So then what I'm going to do is I'm going to do my area that I'm looking for is integral from A to B of, I've defined y1 and y2. I want to do y1 minus y2 for this one. Or sorry, I want to do the curvy, which is the y2, minus the line, which is the y1. So I'm going to write y2 minus y1 plus, So that gives me this region. Now, the next little region is going to be y2 or y1 minus y2. So I'm going to do integral, integral. But now I'm going from b to c, open parentheses, y2 minus y1, close, dx, dx. I should indicate that. So, now I'm going to go ahead and type that into my calculator using fn_int. I'm not going to rewrite all that stuff, but you're going to actually. Sure, I guess I'll write it. But anyway, I noticed that I made a little error here. I switched these two. I said it, I think, correctly. Who knows? Whatever. Anyway, so type this in. If that's the old operating system, if it's the new operating system, it just winds up looking like this. And then you hit enter, and you get, what do we get? 38.795. And if you didn't use these guys stored, then you don't get that exact answer. So I think it's really important to make sure that you use those guys stored. Essential pieces for scoring, if this was an APFRQ. If I'm going to write it like this, and you could write it in other ways too. But I got this guy. I need to identify y1, y2. I can't just assume that they know what I put into my calculator. I need to write using math language, not using calculator speak. If you don't write this, if you write this only, you don't write this, you won't get credit. Write math speak with this after having defined what the A, B, and the C are. Hit enter, boom, get this. This is not essential. I'm only writing this so that those of you with the old operating system or with an 83 can know what to put in your calculator.